Hello children, today's class is related to the laboratory preparation of what? Alkanes. In the laboratory, the alkanes are prepared by the action of sodium acetate or sodium ethanoate with soda lime. In this reaction, there are two questions which are very important. The first question is that what is sodium acetate? Why do we call it as sodium acetate or sodium ethanoate, right? So why it is sodium acetate? Because when CH3COOH, which is basically acetic acid, it reacts with NaOH, right? So what does it give you? This hydrogen is replaced by Na and gives you CH3COONA plus water, right? It's a normal reaction that when acid reacts with an alkali, it forms salt and water. So what is this salt? This salt is sodium salt of acetic acid, right? That is why it is called as sodium acetate. Fine. And because of it could be an ester also, which is called by the suffix O8. It's not nearby right now. That is why it is called as sodium ethanoate. Why ethanoate? Because two carbons are here. So sodium ethanoate or sodium acetate. You can use both the words, but whichever is comfortable to you. So when the sodium acetate or sodium ethanoate reacts with soda lime. Now the next question is, what is soda lime? Soda lime is basically the mixture of NaOH and CaO, calcium oxide, out of which NaOH participate in the reaction and calcium oxide works as a dehydrating or drying agent, right? Absorbs the moisture. Now you may think and you may have a question in your mind that when NaOH is participating in the reaction, not the CaO, then why can't we take directly NaOH and not and why do we take the mixture of these two things, which is called as soda lime? So the answer is that NaOH is deliquescent in nature. Deliquescent means it absorbs the moisture and change into the liquid state. So that is why what? NaOH, pure NaOH is not taken. It is always taken in the form of NaOH and calcium oxide. And the mixture of these two things is called as soda lime. So where NaOH be the part of the reaction and CaO works as a drying agent. Fine. These two questions are very important. What is soda lime? Number one, and number two, why can't we take only NaOH, not the soda lime for the laboratory preparation of what? Methane. Now what will happen? Come back to the equation. When sodium acetate reacts with NaOH, then CONA and here NaO, they what? Combine together to give you what? Na2CO3. Na2, one Na is here, one Na is here, Na2, and here COO is here and one oxygen is here. 3 oxygen. So CO3. Na2CO3 plus, now what is left out is one hydrogen over here and one CH3 over here. These CH3 and hydrogen combine together and give you CH4. Now here point to be noted, children, that in this reaction there is a loss of one carbon atom in the form of CO3, right? How come? See, in the reactant we have taken two carbons, CH3, COONA. So in the reactant we had two carbons, right? But in the product we are getting the hydrocarbon with one carbon atom only. That means the one carbon atom is used up in giving Na2CO3. So what is this indication? This indicates that if we want to take the hydrocarbon of 2 carbon atom, that means in the reactant we have to take 3 carbon, because 1 carbon will be utilized in giving you Na2CO3. Fine. So this time if I want to get C2H6, means I want to get 2 carbon in the product, that means we have to take 3 carbon in the reactant. So what do we take? We take here sodium propanoate or sodium propionate. Both are the name of this compound only. sodium propionate or sodium propionate, right? Why prop? Because there are how many carbon? 2 and 1, 3 carbon. Fine. So it is sodium propionate and react with NaOH. So as usual, this COONA is used up in giving you what? Na2CO3. Na2CO3. Right. And what is left out? Here C2H5 and here is one hydrogen. So what happens? These two combine to give you C2H6. Right. So in that way what happens? You are able to prepare C2H6 when you have taken 3 carbon in the reactant. These are the general method of preparation of alkane. There is one more important question over here, that this is called as decarboxylation reaction. What is called as decarboxylation reaction? D means removal. Carboxylation means removal of carboxylic acid part. Right. So how come it is decarboxylation? You see here, as I told you just now, COONA is the part of carboxylic acid. It is a sodium salt of acetic acid or what? Ethanoic acid. Now when COO group is removed from here in the form of Na2CO3, that means there is a loss of carboxylic group. That is why it is called as decarboxylation reaction also. Children, these small little words are written in between the 2 lines of your book. So, but they are very important. Fine. So, all these things I am telling you, they are highly important. What is decarboxylation? You have to understand why it is decarboxylation. Because there is a removal of what? COOH. Had it not been Na, it would be H over here. Right. So, this is decarboxylation of sodium acetate. You may get the question with that also. Then the general method of preparation. In that what do? We take the mixture of what? Alkyl halide. Alkyl halide means alkyl group is methyl group here. Halide means iodide is here. Methyl iodide or iodomethane. When it is kept with alcohol and the mixture of these two things, alkyl halide and alcohol, is dropped over zinc copper couple. In a beaker, zinc copper couple is kept. So zinc copper couple reaction with alcohol and all, it gives you what? Nascent hydrogen. Nascent means newly born in the reaction. And this works as a strong reducing agent and reduces methyl iodide into methane. So out of 2 hydrogen, one is used up in giving you what? CH4, right? CH3 is what? Giving you CH4 reduced to, and 1 hydrogen is used up over here in giving you HI, right? Hydrogen iodide. So in the same way children, you can get ethane also when you will take ethyl bromide or bromoethane. And a mixture of bromoethane and alcohol is dropped over zinc copper couple. So zinc copper couple and alcohol, they combine together and give you nascent hydrogen. Nascent hydrogen reduces C2H5Br into C2H6, right? And the Br is given out over here in the form of hydrogen bromide, HBr. Alright, these are the general methods. And here only at the bottom there is fatigue reaction also, which is not area of force. So don't do that. Alright, these are the methods of preparation. Thank you children.